All right, so let's say we have a value and we're trying to figure out what tangent of 3 pi over 4 is, and we're trying to figure out what that value is. And we're not trying to use decibels here, we're trying to use our idea of a unit circle. The first thing that I noticed when I did this is that 3 pi over 4 is located about where on the unit circle. So I see the 3/4 as denoting here 75, like 75%, because 3 over 4 is 75%. So if you think about pi, so this is pi, 75% of pi would be, it would be out here. So we're looking at that value right here. So this is 3 pi over 4. So I'm trying to figure out what that would be equal to. So we look at our sine and our cosine values here. We know that it's square root 2 over 2 for the sine term, because it's the value where they're both the same, at least in reference to this triangle. That distance is square root 2 over 2, and this distance is square root 2 over 2. Now the question is it negative here? Like, is that value negative here? Now there's a couple ways of thinking about it. The first way is you could think of cosine being negative here and including the negative here and doing that, but I think it's a little too it's too exact of an idea. There's more of a general idea to understand this. If you think about tangent, my sine and my cosine and sine values in this region of this quadrant right here, my cosine value is my x coordinate, so it's always positive. My sine coordinate is always positive, so it's positive over here. If I look at this quadrant over here, my cosine term is going to be negative over here. My sine term is going to always be positive over here. Here's the situation where they're both negative. And over here is the situation where your cosine term is positive and your sine term is negative, because it's in the negative y direction. It's those negative values over there. So if you think about tangent here, if you think about the quadrants that they're in, you know that tangent is going to be sine over cosine here. So it's going to be a positive over a positive. So tangent is always going to be a positive in this region over here. And if you think about it over here, it's going to be tangent is going to be sine over cosine. So it's always going to be a negative value over in this vicinity over here. So right away, I know that it's going to be negative. Let's just look at what else we have here. So a negative and a negative. So this is going to be positive, because a negative over a negative is going to be equal to a positive value for tangent here. So this would be a positive. And then over here, you're going to have a negative over a positive again. So a negative number divided by a positive number, that's going to be negative. So it's going to be negative over here. So you see how tangent is going to be positive in this quadrant, the first quadrant over here, because they're both positive. It's going to be negative over here. It's going to be positive over here, so these match. And it's also going to be negative over here. So tangent is going to be negative in that way. So you can look at it in this way as well. Think about what sine and cosine are. So it's going to be negative, and then sine and cosine here are both square root 2 over 2. So our answer is going to be equal to negative 1 right there. The tangent of 3 pi over 4 must be equal to negative 1. Let's think about another example. Now, a lot of times we're not given the circle. Let's keep the circle. I don't want to redraw it again. All right. All right, let's say, what about cosecant of 7 pi over 6? Let's say we're wanting to figure out what that is equal to. So the first thing I notice is that So this value, 7 over 6, is a value that's, it's bigger than 1, so it's over like 100%. So this is pi over here, and it's slightly bigger. It's a pi over 6 more. So because 7 over 6 is a value, it's greater than 1. So it's a little, here's pi, and then there's another pi over 6. So this is, we're looking at this region right here. So this is my 7 pi over 6 value right here. If we're looking at that triangle produced here, to figure out what that is equal to, the first question is this number going to be positive or negative? My cosecant is defined to be 1 over, is it sine or cosine here? The C matches with the S, so it's 1 over sine. So it's 1 over sine of 7 pi over 6. And sine of 7 pi over 6, sine, that's negative. It's because my sine value right here is negative, so it's in the, because it's the negative y, because of the negative y coordinate. So you know it's going to be at least cosecant of 7 pi over 6. It's going to be negative here because that number is going to be negative. Now, sine of 7 pi over 6, that value right there, so we're looking here, that's the shorter value. So, and we're thinking about this, so this would be 1/2, so this value would be negative 1/2. So if we take this value here and we replace 1/2 here, or negative 1/2 just in the denominator, what we can do is we can take that value and flip it. So instead of thinking of it as 1 over 2, it could just be 2 over 1. And the reason for it is I can multiply both the numerator and denominator by 2 over 1. So it kind of flips here. So its value is really negative 2 over 1. Let's talk about another example. Let's talk about secant of x, and we're wanting to say, actually not secant of x, let's make it secant of negative pi over 6. So it's a negative pi over 6. So secant matches with the other term, so that's the c term. It's not sine because it's not sine because the s's match, so it's the c term, so it's cosine of negative pi over 6. So we're trying to figure out what this value is first off. Think about our circle, and we don't have to draw the whole thing. So think about this as my x coordinate, my y. If I'm negative pi over 6, so it's going down just a sliver here. I'm going down a little bit, so it's negative pi over 6. So its value, it kind of looks like this. So we're looking at what those coordinates are right here. You know, we're trying to figure out what those coordinates are. This is the longer side, because this is negative pi over 6 as far as our measure, our arc length around. This is the longer side, so this value right here is going to be square root 3 over 2. And then this value is the shorter side, so this is 1/2. Now, if you look at these values here and here, and these are just distances here. And we're trying to say, well, our cosine of minus pi over 6, what is our value for cosine right here? Our cosines are x-coordinate. Our x-coordinate is positive right there. So our x-coordinate is going to be square root 3 over 2. And that's going to be what our cosine term is going to be for negative pi over 6. So it's going to be 1 over square root 3 over 2. And make sure the denominator is a little bit larger there. It's important there. So that value, if we're going to take that number and flip it, we're going to multiply by 2 over square root 3, take the reciprocal of it. So in other words, this value for our secant term right here, secant of minus pi over 6 is going to equal, these cancel out, 2 over square root 3. We're not done yet. And notice what happened in that process, in that long process right there. We had square root 3 over 2, and these just flipped here. Because of the relationship between cosine and secant here, we could just take our values and flip it. So we don't have to do that reciprocal process every single time, but it's a good idea to at least see every once in a while. So we're here now, so we have 2 and square root 3 here. I'm going to have to get rid of that square root 3 in the denominator because I don't like square roots in my denominator. So I'm going to have to multiply that by square root 3 to get that out. I have to multiply up top by square root 3 to get that out. So therefore, secant of minus pi over 6, that value must be equal to, so square root 3 times the square root 3 is a 3. And then 2 times square root 3 is just 2 square roots of 3. Our radical, our square root is in the numerator. It's good. And then we leave it like that. And that's how we would figure out what secant of negative pi would be. Let's do a couple more. Let's do a couple more. Let's do secant of minus pi over 2. Let's figure out what that would equal to. All right, so secant is the cosine term, so it's 1 over cosine of negative pi over 2, cosine of negative pi over 2. If we're looking at our unit circle here, we're going all the way over here, negative pi over 2. Our x-coordinate is 0, so it's 1 over 0. That value is, so if I ask what the secant of negative pi over 2, that value is undefined. We cross that thing off and we write undefined. Okay, we don't have a definition for it. So if I give you that value, I expect you to understand that that value is undefined and write that value. Write what that is there. That's an important aspect of these functions as well. So it's undefined right there. Let's do. Talked about secant. Let's talk about cosecant one. Cosecant of, let's say, 5 pi over 6. Okay, so cosecant of 5 pi over 6. All right, so 5 over 6 is a number, it's less than 1. So it's like, it's not going to be, here's pi. It's not going to be greater than pi because that 5 over 6, thinking about that percentage-wise, it's a little less than pi. So this is pi, 5 pi over 6. And this would be all the way around to pi. So this value right here would be 5 pi over 6. If we think about our cosecant terms, so here's 5 pi over 6 right here. This is pi going all the way around. This is my longer side right here. So this would be square root 3 over 2. This would be a half. Cosecant. Cosecant goes with the c goes with the s term. So it's 1 over sine of 5 pi over 6. Is sine positive or negative here? Sine. Sine is the y coordinate. It's a half. It's positive here because it's up above. So it's 1 over a half. In other words, I can take that number and flip it, so it's just 2. Or 2 over 1 or just 2. So that's how you would do that one. And then I'm going to talk about one more, and then I'll be done with this video. All right. Let's talk about secant of 5 pi over 4. Okay. secant term goes with my cosine, because the s goes with c. So it's going to be cosine of 5 pi over 4. 5 pi over 4, if we look at that value, it's going to be, it's a little more than pi, so it's right up here. 5 pi over 4, if we're looking at that value, we're going all the way around 5 pi over 4. Here. Think about it. The way I do it is that, so this value will be, it's the same region as the square root 2 over 2, square root 2 over 2. Cosine of 5 pi over 4, my cosine term is going to be negative, so it's going to be negative here. So it's going to be 1 over a negative square root 2 over 2. So I can take this value and multiply it by 2 square roots of 2, 2 square roots of 2. You know, the same thing. I'm taking this value every single time, and I could cancel out those terms if I wanted to. I'm taking this value here, and then I'm rewriting it over here. So it's written like that. These cancel out. And my negative is coming from right here. So 2 over square root of 2. Right there. So that is equal to, we don't like square roots in the denominator, so I'm going to make it, there's a negative. And now I need to get rid of that square root 2 in the denominator. I'm going to multiply it by square root 2. So I know that that value is going to be negative 2 square roots of 2 over, all right, square root of 2 times square root of 2 is 2. Oh, check that out. That canceled. Oh, so that is really equal to negative square root of 2. Because the 2's cancel out right there, so this value is saying negative square roots of 2. So secant of 5 pi over 4, that value is really negative square root of 2. All right, so that's the idea of going around here. Again, 5 pi over 4 is over here. So 5 pi over 4. When you get quicker at these and when you get faster and faster at these, you start realizing where these are located, and you jump right at the triangle. And that's what I was trying to do on that last one right there. So, all right, I hope this video helped as far as understanding, you know, how to figure out what those values are.